What's up? Welcome back. Today we are working on implementing zlib in Zig for no reason other than it would be fun. It's one of those things where I've never really looked into like how lossless compression works, and it feels like I should have some sort of inkling of what it's doing because it's used everywhere. And so it would be nice to say, well, how does zlib work? How can we implement the same thing? Blah, blah, blah. At the same time, I've been like looking for an excuse to learn Zig, so we're implementing zlib in Zig. We're calling it ziglib, which is a bad name, but it's fine. And we're just doing to learn both. So where we're at right now is you look up zlib on Wikipedia, and it brings you into this like deflate algorithm. So zlib is kind of like a header that tells us how the deflate stuff is stored, as well as this like deflate compression. And we haven't really read the whole thing, but it looks like they have a few types of blocks. They have like either something is just normal text. If we compress it, it doesn't get any smaller, so we might as well store the whole thing. That's just like the original input. So you can imagine something that's already compressed, you wouldn't compress it again. Then there is Huffman coded blocks that are using some pre-agreed upon inputs. We'll explain that a little bit in a second. Then there's like dynamic ones where like the Huffman coding is dependent on the text itself. So you can imagine that if you had text that was like a bunch of A's, you could represent that A, like maybe a bunch of A's and a couple B's. You could represent that text in one bit, right? Either you're going to have 0 for A, 1 for B. But then if your alphabet becomes bigger, you need more bits to represent the differences between those characters. And so this will like look at the text that you are currently encoding in this block and try to generate like a more efficient representation for it. And so what we've done so far is we've written this like Huffman table generator. So the idea is if I have this text, it's like A, B, B, C, C, or something, right? Maybe we'll put a third C in there. So the idea is you look at like, you take this text and you say, which character was the least frequent? In this case, it's B. And so you like create like a branch of a tree and you put a B in there and you say, what was the next one? The next one was C. And what was the combined probability of these guys? Well, it's like 5, right? And then there's 5 A's. So then you say, okay, we're going to take like our A, which has a probability of 5, and our BC, which has a probability of 5, and we can put this in like a tree that looks like A, B, C, right? You could put, really, these could go in any order, but we're sorting alphabetically first for whatever reason. Maybe we'll add one more A here so that the A has a probability of 6 so that it like makes sense for it to be encoded slightly less, with less text or less bits. And the idea is you can walk this tree and you can say, okay, in a single bit, we can store which path we took at that point. So you could put like 0 here goes to A, and then 1 goes to like this second branch, 0 here goes to B, 1 goes to C. And so then you have like your code book of A is a 0, B is 1, 0, and C is 1, 1. And that's how you like store this stuff in a file. So what we've got right now is we've got like generation of this tree. We would like to be able to use this tree to generate data. So that is where we're going here, is to try to figure out how do we like put this into text, and or how do we like compress some text using this, and how do we decompress some text using this. That's the plan for today. So approximate plan of action is we have to write a Huffman encoder. So last stream we added, well, Zig standard library has this way to like pack bits into a stream so that like I can like, because usually when you write like to a file, you can only write one byte at a time, but we want to write like 1 bit at a time. So Zig standard library has a bit writer. We wrote our own because it was fun. It's probably worse and less efficient, but it was fun. So we'll use that to make our Huffman encoder. We can like basically walk a bunch of inputs A, B, C, D, and just like look up which bits go into the bit stream. Great. Then we can like write a Huffman decoder that uses the same tree. And then we have to find some sort of way to store the Huffman tree so that it can be like loaded from a file. And I'm tempted to do more than that, but I'm not really sure how long this will take because I'm unfamiliar with Zig and stuff. So we'll kind of see how far we get. And if we get farther, we'll get farther. We can just keep going. Yeah, okay. So let's just get into it. Let's start looking at writing a Huffman encoder. So last stream we have this like bit writer, and some example usage here is we try to write in like, here are 3 bits, we write 3 bits, and so the idea is we are writing them in a way where the first thing we get that gets written is like the lowest bit. So the idea is that if we were to push in the bits like 0, 1, 1, 0, 0 or something, this would get stored as a single byte of 0, 0, 1, 1, 0, right? So the thing that gets pushed first is like the least significant bit. The spec for deflate kind of like says that that's how it's supposed to go. And the idea is that if you were then to look at a file where you have like byte 1, byte 2, byte 3, you start at the lowest bit on byte 1, and then you just walk your way up to the most significant bit, then move on to byte 2. So we have like this API where you can write in like several bits at a time. So here we write in 100 followed by 110 followed by 11 by 101, and if we run this guy, we see that this 100 gets placed at the least significant thing in the first byte. 110 is like the next thing up. The 11 gets stored here, and then the 101 gets stored in the next byte. We are chilling. So I think the first thing we want to do here is we want to like wrap this like bit writer with some sort of like Huffman, like something that's like coding normal values. So we want to maybe say like, I kind of want this to be a new file, so we'll call this Huffman writer. And I think we're going to follow a similar pattern that we did for the bit writer, where we're going to maybe wrap, because like we might want to write to a file, or we might want to write to an array or whatever. Our bit writer supports taking in any type of writer that implements like Zig's standard write API. And I guess we also will need to take in a writer, as well as probably a table, like a Huffman table. So our Huffman table type is called Huffman table. So we'll call this Huffman writer. He takes in a writer as well as a table. Well, maybe a table isn't what we want. Maybe we only want like, on writing, we don't ever need to walk the tree. We just need to look up what the code is for any given input. So maybe we'll say that we're gonna like take in a writer and a codebook, we'll call it. And I think in this language, I was gonna say we do snake case here, but I think codebook is one word. And so I guess this will be some sort of codebook, which we are saying is one word, not 2 words. Which means that we need to like define the codebook type. So say codebook is going to be a lookup table for any byte, I guess, right? You take 1 byte of input and you find the equivalent bits for its output. So this is going to be a 256 long U8 buffer. But maybe not a U8 buffer, because you need to know how many bits you're writing. So maybe we also have like a code. Maybe we don't want to call it this, but we'll figure it out later. And he is going to store 1, the value that he's going to write, as well as how many bits from that value he should write. And I guess technically this could be like a U3. You can't store more than 8 bits in a U8. And maybe by doing this, you kind of ensure some type safety where you can't like accidentally try to flag more bits than you can possibly write. And so this is going to be a bunch of codes, not U8s. And this is going to return our Huffman writer type. And so this is like a function that will return a type, and this is a type. Maybe. Maybe it's not. I think this is also a function, but the function was going to return a type. Yes. Because it's going to take in a writer type as its input and return a new type as its output. Little Zigism here, right? So in Zig, instead of writing like generics as like C++, where you would write like template, type name, T, you would have like struct Huffman writer, right? And then in here, you would have, like, writer is a T. Instead of, like, having generics, they have functions that run at compile time. And we generate a new type on the fly that has an embedded writer inside like this. You would be like struct, return a struct that has a writer of type writer. And I think that here the convention is your parameters are capitalized if they are type parameters so that we can do stuff like this and it looks okay. And then we also need to store the codebook. So the codebook is going to be of type codebook. Okay. Which probably means that this needs to be public, and probably this needs to be public as well. Okay. And then this stuff is no longer bitwriter. This is Huffman writer. And he says, hey, the type of this guy is going to be depend on the type of this input here. And we need this guy to have like some sort of initializer, probably. And he's going to take in a writer of type writer. And he's going to take in a codebook of type codebook. And he's going to return a Huffman writer. But here, he actually needs to define the type. So we do something like const self is equal to this, I think. And then Zig goes, hey, I have like an anonymous struct here, but I'll name the type inside so that I can use it, and then I can return itself here. I think, and then I just say return. I think it's like this, and then I write writer is equal to writer, and codebook is equal to codebook or something. Arguably, you shouldn't be passing around, you shouldn't be like mem copying this 256 byte codebook around. So maybe this should take in a codebook pointer. Like this. And then we would just have to document codebook needs to live for longer. It needs to be valid for the lifetime of Huffman writer. Sure. Yeah, sure. Seems fine to me. Seems fine to me. So this guy's also going to take in this function is going to take in a const codebook pointer, and he's going to pass it on here. And he returns a Huffman writer. Okay, so in main. This is actually, we have to get a little tricky here. This writer is not the bit writer. He's going to be, we need to like convert him into a bit writer. So we're going to say const bit writer is equal to import bit writer Zig. I think this is how you're supposed to do this. And then here, the writer is going to be bit writer, writer. Bit writer, writer. So here we have to specify bit writer. Can we like do, we need to define like a new type name here. So maybe we'll call it like, yeah, bit writer, sure. But that feels kind of weird. But that's okay. That's fine. We'll say this is bit writer of writer. Our bit writer is a bit writer. What the fuck have I written here? That's okay. Well, we can always adjust. We can always adjust later. Okay, does this compile? Maybe. Let's find out. equal, so we import the Huffman writer, and then we try to use it. Yo, dog, I heard you like bit writers, so whatever the fuck this is. Good one. Okay. So, we have this bit writer, and so we don't construct the bit writer here. We construct it inside the Huffman writer, which I don't know, maybe I don't like that. Maybe you should construct the bit writer outside, but whatever, that's fine. Okay. So let's try to make one of these things. We'll say var Huffman writer. Oh, this is weird. I'm like name colliding here. Because here I've imported this thing with underscores, but I'm also trying to use this guy with underscores. So how do I avoid that collision? Zig naming conventions. Like surely there's, I'm not supposed to name these the same way. Zig import snake case. Is that like, ugh. I guess we could just look at some example code. I know I heard that bun is written in Zig, and it's like a big project, so maybe we use that as our reference. It's the only big Zig project I know, off the top of my head. Import the function from the struct. I could, but I just want to like the concept of me having to name modules this way seems confusing to me. So these guys, they import the structs directly. I see. Here they are using snake case here, and they are using. Do they use snake case for variables names as well? Are there any multi-word variables in here? Yeah, I guess they do. So I guess I just have to be careful. I guess I just have to not collide. Just fine. We'll just call it writer here. And then we can say Huffman writer dot Huffman writer. And we pass in a writer that will wrap our U8 buffer that we make here. And we need to pass in a codebook too. Tiger beetle might be another good example of a Zig codebase. What's tiger beetle? Tiger beetle. It's an insect. Is that big, or is it just really zoomed in? How big is this thing? Dude. That's really fast. That's a fast-ass bug. How big is that thing? This doesn't matter, but I'm curious. Looks pretty small. Oh, I guess you could do the math here. 125 body lengths per second is 2.5 meters, so divide by 125 and you get something that's not very big. Okay, tiger beetle Zig. Distributed financial transactions database. I've heard bun might not be the most idiomatic at times. Oh, okay, that's good to know. So I could use this as another example. But here they're definitely naming modules with underscores, and when they like pull stuff in, I'm assuming that they also pull in with underscores. Global constants, yeah. And yeah, okay. Naming guide can be found here. Type should be this. Camel case for callable, otherwise snake case. Yeah, okay. So they are just hitting that where they have. What the fuck is this syntax? What is happening here? You double escape the beginning of a line to make a string? Crazy. I've never seen anything like that in any language. That's interesting. Okay, but yeah, I do just have to avoid the collision, which is fine. It's fine. Doesn't matter. Okay, so I need to generate the codebook. So maybe this like codebook thing shouldn't live here, but it should live in like our Huffman table stuff. I think that probably makes more sense. So we could say huffman is equal to import huffman.zig here. And then here we say, or I guess we can just say const code book is equal to this code book. Here we go. And then here we're going to have to make some sort of function generate codebook, who takes in self by reference, probably const. He probably doesn't need anything, and he's going to return codebook. Yeah. And maybe instead of returning a codebook, he takes in a codebook by pointer. Because I haven't really decided if I think it's reasonable for this thing to be on the stack or not. So it seems like somebody constructing a codebook where they want and then passing it in for initialization seems reasonable. You could also argue that, like, we should construct a codebook from a Huffman table, but, like, you could have, like, codebook.construct in it with where you pass in the Huffman table or something. But this is fine. This is fine. And then, can I just, like, panic here? Like, assert debug, assert false. And then here I say, hey, I've got some unused shit. Uh-huh. And then here I can then say that I need to create my Huffman table. Which we have commented out down here. So we have some table, and we construct a writer from this, and var codebook is equal to undefined, who this is going to be a Huffman codebook or something. Then we pass in this guy as codebook here. No, not like this. Huffman. We have our table.generate codebook with the codebook. Nice. Then we can pass the codebook in here. Like this. And we have a writer now. And then we can try to write something. So here we have no function yet. So it's gonna be some function that's like write. And we're gonna take in self. And data, which is going to be some slice of U8s. And this is not implemented yet. So std debug assert false. But we don't have std yet, so const std is equal to import std or something. And we say, I'm not going to use this shit, so that Zig doesn't get mad. Now we can write some data. And since we are writing to our buffer, we should be able to print out the buffer at the end, and that should tell us if we encoded this stuff successfully. I should just slap a temporary unreachable in there. Okay, so Zig will... Sure, yeah, it's kind of the same, effectively, right? Because both will, in debug mode, crash, and in release mode, do nothing of value, probably. Expected a U8 slice and found a pointer to a U8. Oh, because this guy needs to take in constant. Like this. Okay. But now we are just hitting an assertion, which is reasonable at Huffman line 96. Okay, so we compile, which means we've done something right. Well, it doesn't mean that, but we can infer that we've done something somewhat right. And here, to generate our codebook, we have to just walk our tree, and for each value, put in a code. So I guess actually our codebook is going to have a bunch of maybe codes, right? Because there's going to be a bunch of, like, if there are things that aren't in our input, then they're not going to have a code associated with them, right? You can imagine if you generate a Huffman tree based off of this data, where you say, hey, we have A's, B's, C's, and D's, and please like generate bits based off of the frequency of them, then there's going to be a bunch of stuff like if you try to use the letter E, it's going to be like, I never saw letter E, so I don't know how frequent it is. It must not exist. E's don't exist. So here we'll put a question mark here to say we might have codes that we didn't create yet. And so I guess before we do anything, we are going to like have to memset all of the values in the codebook to a specific value. And I guess memset is not what I thought it was. I thought that they had memset as a compiler built in here. Memset here. So yeah, memset dest element. So I just want to set everything in. Dest must be a mutable slice or a mutable pointer to an array. Okay, yeah. So I just say, hey, could you set everything in the codebook to null? And that's how we'll start. Then I have to do something. Which is, we're gonna have to like walk the code table. Memset only accepts bytes, so you might have to use mem as bytes codebook. Interesting, let's see. He did compile. He seems like he's okay here. Unless it doesn't, like, it's not gonna do a sane check here at runtime. It does say that he doesn't really claim anything about a region, like, restrictions on the element here. Okay. So, we're gonna start at the root. I guess we've, like, kind of already done this, but, like, we're gonna wanna walk the entire table. So, we're going to start at the root, and we're going to continually push in like left or right branches taken. And then when we find leaf nodes, we're going to stick those nodes. We're going to like look at the value at that node, use that as an index into our codebook, and write the path that we took to get there as the value. Right. So, right. So I guess that's just going to be basically this code that we wrote at some point to walk the tree. Which means we kind of need an allocator here, I guess. Technically, we've been provided an allocator here, but I don't think it's reasonable to assume that that's the same. Sure, let's just take in an allocator here. I'm not sure if I want to do that, but whatever. And do we usually take in the allocator by pointer? No, we just take it in by value. Or at least we did last time. Who knows if that's correct? Okay. So now, here, when we generate our codebook, we have to pass in an allocator. Okay. And so we start at the root, and we just walk the table. This is probably inefficient, like where we're... Let's think about this. Yeah, there's something stupid going on here where we are walking the table every iteration here. So what we should be doing instead is we should be saying, hey, how did we get to this node? And also, what is our current node? I guess he starts as undefined. And here we'll just say that he's a node. Or he's like probably a usize, I guess. He's like an index into our list of all nodes that could exist. And I guess he starts at 0. No, he starts at the root. Yes. So here we have stored somewhere. I think the root is the last node. Something like this. Yeah. Okay. And so as we walk, we say, hey, if we hit a leaf node, so the node is going to be self. I guess here we'll call this node index instead of node. And then here we can say that the node is a reference to self nodes items node IDX. And I guess maybe we don't even need to store the index. Maybe we store the node directly. Probably that's what we're going to do. So we're going to store the node here, and he's going to be a reference to a node. Pointer to node, sorry. Languages are hard. And here he's self nodes items, self nodes land -1, blah blah blah. This has to be right. Pointer, I think. Yeah. Okay. So if he finds a leaf node, he's going to say codebook at node dereference. I guess I need to take this thing by leaf, we'll call it. And then we say leaf is going to be a U8, which is where we are indexing into our codebook. And he's going to equal the path. But the path is like this weird, like vector of bytes, which maybe he shouldn't be, right? Maybe we should be able to just like use the path as is, but it's fine. And so we need to say like path to bit representation. And we take in path. And this function doesn't exist yet. Otherwise, if it's a branch, we try to walk down the left side and continue. And then otherwise, we need to update the node here as well. So here we say node is equal to self nodes items at our node left. So here, I guess we have to take in the branch by value, actually. We take in the branch, and we say, hey, can we look at branch left. So now we've reassigned the node. Oh, interesting. So this is probably why we did it that way before, is because when we pop things off the path, we have to retrieve where we are. Okay, fine. Var node equals node from code. Yeah, fine. And this is path to bit representation with camel case because it's a function. It's callable. Which means now we need some sort of function. Path to bit representation. And so we're taking a path, which is a const array. Like we want like a slice, I guess, of U8 or something. And he returns a U8 or something. I don't know. We'll figure it out. Code might not fit in U8, but for now, we're assuming it does. Okay. So here we say that this is unreachable temporarily, and we say, hey, ignore the fact that I'm not using this guy. let's just double check that everything's happy, and it's not, because we can fail on this, which means that in main we have to note that we might fail. Node from code. This can be const. He doesn't like that path here needs to be path items. And path bit representation also should be path items. Okay. We chillin'? Expected type Huffman code found U8. So this guy should return a code. Which means that this fix me should actually go up here. There we go. Expected type Huffman node found Huffman node. Oh, we don't need to do this anymore. And this is unused capture. Okay. And now we're hitting the unreachable at this codebook generation. Sick. Okay. So it's going to be something like the path is stored as like 0, 1, 0, 1, 0, 0 something, where this is like the first branch taken, which means that we need to take each value in our path and OR it into some value. Right? So we're going to do something like for elem in, there's no for elem in, for path, we get val. And in here, we're also going to, we're actually going to want to go for each index in 0 to path len. Then we can say that the val is going to be path I. I guess yeah, that's fine. Here we're going to assert that val is 1 of 0 or 1, so less than 2. Path should only have 0 or 1. And then if it's 1, we have to like append this to the code. So code or equals val shifted left by I. I think that's it. So yeah, that seems right. And so then the code that we return has a code of code and a num bits of path len. Yeah, easy. Maybe. And I guess, you know, if we want to be thorough here, we could say bit representation from path. We could write a test that's like, hey, so I have some path that's, how do you do, like, generate an array in this language? It's like this. So here we say, like, we want, like, 0, 1, 1, 0, 0, 1. And we expect path to bit representation of path. Stood testing, what is it? It's like stood testing expect equal. We expect the bit representation of this guy to be 100110, right? Because we're going right to left here. And I guess we're actually expecting a code equal here. I don't know if you can do equals equals on like structs in this language. Probably not. That would be my guess from like everything I've read about Zig so far. Zig struct equality. Probably we have to do like a memcomp. Probably. Stood meta equal. Nice. So this should be expect, and we can do stood meta equal, and the thing on the right should be a code book, or code, where he has the code of this, and num bits is equal to 0, 1, 2, or 1, 2, 3, 4, 5, 6. All right. Okay, so he doesn't like... But this guy needs to say that he's like a U8 or something. So it's like as U8 0 or something. Expected U3, found U size, so as U3. The fuck? Found expected type U3, found U size. But I said as U3. So what's it bitching about? I pass in a type, okay. Am I high? What doesn't he like here? 3-bit int cannot represent all possible unsigned 64-bit values. Sure. But, like, why does it... var code U8. Oh, yeah, that's a good point. I should do this. This makes more sense. Int cast? Do I need to int cast? But, like... Oh, because as is unambiguous and safe. Right. So you guys are saying there's a separate function, int cast, which converts with runtime checks. So here I can just do probably int cast without the as u3. Probably. It'll probably figure it out for me. Okay, cool. No field name, code, instruct Huffman code. So what is it called? It's val. Which means down here, this should be val. Okay, and we are close. Expected u3, found u size. Right, so here I guess we just do int cast, and we don't need to do any assertions because the int cast will do the assertions for us. So we're chilling. Okay, zig build test. He doesn't like this because this guy is saying that I could be mutable. He'd have to be mutable. He can be constant. Who fucking cares? And this expect is ignoring an error. So I have to write try here, I guess. And now he's succeeding, but let's like kind of like put an error in this test to make sure that our test is testing something of value. So he is failing that test, which is good. So here I just put that back the way we expect it to be, and we are chilling. Big chilling. Okay. So we probably have a codebook here. Yeah, you want me to use expect equal deep? Where's the standard library docs? Here. Testing. I guess it's going to do some sort of like intelligent... This function is intended to be used only in tests. When the two values are not deeply equal, prints diagnostics to stood error to show exactly how they are not equal and returns a test failure. So I guess the idea here is that it's going to do some sort of like metaprogramming to figure out what the fields in my structs are and like do some sort of fancy schmancy comparison. Expect equal deep. You get more diagnostics, I think. So where is this deep inner? So he gets the type info, and if it's a struct, he iterates over the fields of the struct. Interesting. And so you can actually do that. Interesting. So there's like kind of reflection in this language. But it's not like runtime reflection. He's taking in the type as a value and iterating the fields of the struct, which will probably compile down into just like pointer offsets. That's interesting. That's super interesting. That's very cool. Yeah, that's super cool. Interesting. Yeah, there's compile time reflection. Type generation is also possible but discouraged. Dude, do you know how fucking sick this is? Like, I feel like I'm like, my mind is just like, holy shit. Because this is like, obviously you should be able to do this. I wanted this for C++ my whole time where I was working on it. Right? Where you're just like, what the fuck are the fields of these structs? Like, what the fuck does this struct look like? Like, what are the values in it? You just want to be able to like print it, and you like can't. You have to like write a actual, like, you have to like copy paste all the field names or use a macro when you declare fields. But here they're just like, yeah, of course we fucking have that information at compile time. Why don't we just give it to you? That's so fucking sick. I remember having to use this like compile time reflection boost. God, I'm not gonna be able to find it. But there was this like absolutely fucked library that you could use that like kind of gave it to you, but it was like really fucked. I don't know if this is it. Anyways, that's super cool. That's super fucking cool. What a cool language. It feels like to me I'm like what 3 days into Zig, so whatever I say is completely invalid and useless. But it feels so much like if they did C++ right so far. Right? You have kind of all of the things that you're missing in C that you get in C++. They just make so much more fucking sense. Like, so much more sense. That's super cool. What language is Zig closest to, and why is Zig over that one? I don't know if... It doesn't feel like anything I've used so far. It's like... It's a lot like C in a lot of ways. I think it's a lot like C++ in some other ways. Kind of like Rust in like some of the focus on safety, that like it's kind of like upgraded from C to say like, hey, we don't want you to like, we're going to do some runtime checks for you in debug mode that you wouldn't get naturally in C. Why use it? Yeah, that's what I'm trying to figure out. Because I've just heard a lot of good things. I've heard a lot of praise, and I'm writing a project in it now to try to like get a feel for what that praise is. And this was like a big unlock for me just now. Okay. So we probably have a code book, and it'd be interesting to maybe print the code book. So can we just say like std debug print? Can I just print the code book? I wonder. Zig is fairly similar to other Algol family languages. What the fuck is Algol family language? Algol 60. What the fuck? History. Research. What year is this? 64 years ago. That's it. Okay, this is some comp sci shit that I'm not going to get into. Have you seen Jai? Some game devs are switching from C++ to Jai. I've heard some things about it. I would imagine, like, is it, like, available and, like, used by people? I've kind of thought it was, like, just, like, that one guy's programming language that he uses and writes. But, yeah, I don't really know. Beta testing. Interesting. Okay. What was I trying to do? I was trying to see if our code book looks reasonable. Zig build run. So cannot format without optional specifier. Because optionals. I see. So they're saying I can write the word any here. Or a question mark. Cannot format array without specifier. So do I just write any here and then it figures it out for me? Why doesn't it do that by default? Okay, here we go. How can it print? So does this mean that every single structure has a default formatter built in? Because I didn't write anything for this. And I seem to remember having to write a formatter for a union earlier? Did I just not have to do that? That's pretty cool. Okay, so we're saying that the vast majority of all possible characters have no inputs, but the characters A, B, C, and D do. And A's value is 1 bit, B is 2 bits, C and D are both 3 bits. Interesting. Okay, which means it means that if we write A, B, C, D, we should be able to get something out, but we haven't implemented this yet. So let's see what happens here. So for each value that we get in our data, we are going to look up the data in the codebook. So codebook V, and I guess we want to take a pointer to that thing because we don't want to copy it needlessly. And so we're going to say we're going to like get the code, const code is equal to this. And we're going to look at the code. And we're going to look at his num bits, and we're going to use that for our writer. And we're also going to look at the value. And we're just going to say self writer write, and we're going to write the code val and the number of bits. Except this isn't going to work because he's going to say, hey, this thing's an optional that you just got out. So clearly that won't compile. And so how do I, like, unwrap the optional? I have to do, like, if this thing exists, we propagate the code back like this. Else, I guess we panic and say or I guess we just fail. We don't need to panic. We can just, well, I don't know how I feel about like runtime error versus compile time error, or like do we think that this is like a user error or a programmer error? Probably user error, right? Because you don't know, like, us doing the validation here seems reasonable. Now you could argue that you shouldn't write any data until you know that all the data that you're trying to write is valid. But we'll see. You guys are saying I should write X or else. Oh, right. I saw that somewhere. I saw that in the language reference. Like there's an or else keyword. Optional unwrap. Yes. So, but I want the pointer to the optional, which is kind of confusing. So I guess I do this. Zig pointer to optional. Like, I assume that the pointer to an optional, like, okay, here's what I'm thinking. I'm thinking optional is probably stored somewhat as something that's like, is valid as a bool, as like 1 bit. And then like value as the value. But like, I want like a pointer to this thing, but I guess depending on how it's packed, like getting a pointer to that thing might not be valid. I don't know if that's like a legal thing I can get a pointer to, right? Because I would also, like, if you have an optional big thing, can I turn that into a pointer big thing? Is that like legal in this language? Zig optional to pointer, right? Like I want to like unwrap the optional and turn it into a pointer because I don't want to copy the big thing necessarily. I mean, not that it fucking matters here. I'm just trying to get a feel for the language, right? Because I would think that this should be my default. Okay, so let's see. Blah blah, or else expression. Blah blah blah. So here I have. Oh, there is. This looks a lot like this will certainly do like the reasonable thing. Certainly. So here I would just say, hey, I'm going to take the thing and do this. But then, like, what happens if this fails? This is shorthand for or else unreachable. Okay. So I first need to validate that it's valid. So here I want to say, if code dereferenced is equal to null, then I continue. And then here I know that it's valid, so I can just unwrap the optional every time. I guess that's probably what I'm supposed to do. Maybe. Let's see. Zig pointer to optional unwrapped. Like, is this something? Zig optional storage. Can I do like? I wonder if you can do something crazy like this. I wonder if that's legal. Because that's kind of what I was initially thinking. I check if the thing is null. If it's not null. Also, wait, hold on. This is going to be copying every time too. Am I supposed to do for and data? What is it? What is the type of this thing? Like, type of V. Like, what is this? I'm so lost. Comparison of U8 with all. Oh, right, because this is, this is the data. Oh, but you can always take in this thing by pointer by doing this. That's good. That's what I was trying to check. Okay. Okay. So here, I want to do if self codebook v. I'm also a little bit confused by if I like index this array by v, this isn't going to like inherently create a copy. So here I want to do something like, hey, let's look at the thing. And if code opt is equal to null, then I continue. Here we go. And then if now I'm like, okay, now I know that it's valid. So I can say const code is equal to the reference of code opt dereferenced unwrapped. I think. And then I can use the code just like as a pointer without worrying about it. Error is ignored, so we try here, which means that we have to try with assist to return an error. And in main, here I have to try here. Zig chatters. Is it normal? Like, what is like error conventions in this language? Like, am I supposed to say like write error here is equal to an error with some stuff in it? Like, am I supposed to do that? And am I supposed to then like return my write error here? Or is it more normal to just like use like the global error type and just let it deal? Like, when would I not use the global error type? You know? I don't know if I'm like missing something here, because it feels like I just would, I feel like I would almost never use it. Typically better for public interface since it gives more info. Oh, so I want to like explicitly say the ways that I can fail. And if I give a list of ways that I can fail, the compiler will be like, what the fuck? I can't coerce into that type. So if I were to like be like, type write error is equal to like out of memory, like, or, you know, some special error, right? And this is the only thing that I can do. Uh, type, or it's const, sorry. Const right arrow is like this. Then if I were to like put the word right arrow here, it would be like, it should complain that the right, this doesn't like coerce properly. Ah, yes, yes, yes. Okay. So this way I can like enumerate all of the ways that I can fail, and that gives information to people who are calling me to think about like the types of errors that they have to handle. That makes sense. That makes sense. Gotcha, 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 gotcha. I'm not going to do that right now, but I could. Okay. So theoretically, everything's working here. So let's say that I write the letters like A. Given our code book, we should expect that to come out to a bunch of zeros. Instead, we get nothing because we didn't flush our writer. So we need to defer. Maybe we need to, like, at the end of this, writer flush. Which means that this guy has to have, like, a pub function. Oh, I think we called it finish in our other thing. Which means we have, like, self writer finish. And I don't know, maybe it's not, like, not very ziggy to do it this way. Maybe it makes more sense to just expose the writer and say, hey, you can finish the iterator if you want. But maybe we just do this. Okay. So he has the string 0 in him, which is kind of interesting because you can't really tell when you look at this how many zeros are packed in here. Right? This could be anywhere from 0 to 8 zeros. But I think the zlib convention is that you say how many bytes you want to decompress from this. So I need to know the length of the string that I'm decompressing to know to only look at the first 5 bits of this thing. Okay. Cool. So let's do something a little bit more interesting. If we say B, 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 we should see 5 ones here. Oh, we don't. We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting, because we say that the value for B is, hold on, let's get this again. Val 0, numbits 1. Val 2, numbits, val 3, numbits 2. Oh, oops, my bad. B is this one. Yeah. So we should see 10 ones, which we do. Nice. Here we have D is value of 5, so 101. So if we write D, we should see 101 5 times. So we see 101, 101, 1, 1, 1. That seems wrong. 101, 101, 101. So there's a 1. Oh, there's a 0 leading at the beginning of this. 1, 2, 3, 4, 5, 6, 7, 8. There's the 8th thing here is a 0. We should change our formatting here so that we always show 8 bits. Which is probably like something like this. I don't know. Probably like this. Oh, wait. No, I'll have to look it up. We can just look at the fucking answer. Specifier. The digits after the colon is interpreted as width, not fill. If fill... Okay, note that most of the parameters, blah, blah, blah. It may be omitted. You can leave out colon dot. Oh, so the fill is a single character used to pad the formatted text. So it's 0. Alignment, blah, blah, blah. So it's colon fill dot fill alignment width. If fill is required, one has to specify as alignment as well. What is alignment? Is one of 3 characters. This, or this. Left, center, right aligned. Okay. So here we say 0. Fill with zeros, right aligned, or left aligned to 8 width. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Left aligned. Right aligned, I mean. There we go. That looks more right. And then I guess we also say lead is 0B on here. Nope. Can I ask the formatter to put 0Bs for each element? I guess not. Specifier argument. Specifier, blah, blah, blah. Yeah, okay. That's fine. That's good enough. Okay. So 101, 101, 101, 101, 101. Nice. Nice. Okay. So I think that we can say that after an hour, we've got a Huffman encoder done. And we can also say that we did some other stuff along the way here. We serialized our code book. Oh no, we generated a code book. We did not serialize it. We used code book to write to bitstream. I guess that's kind of all we did, huh? Felt like a lot more. But what you gonna do? What you gonna do? Okay. So now let's try to take our buffer and like decode it. So we can say something like var input data is going to be like a slice of U8s, right? And he is going to start as A, B, D, D, D or something. Fuck it, right? Doesn't really matter. And so we're going to write the input data down here. Okay. Then we're going to try to read back from that thing. So let's make a new Huffman reader. Okay, and this is gonna... What? He's gonna have some struct that's like a Huffman reader. And I guess he's actually gonna be a function, Huffman reader, who is going to take in some form of reader. Comp time reader, who is a type. And he's gonna return a new type. And the type is gonna be like something that has... he's going to have like the bit that so he's going to parse some amount of bits at a time, but the reader is only going to give us 1 byte at a time. So we're going to have to say like current bit is a U8 or current byte, and byte, how far we're into the byte is going to be, you know, U3 or something. How many bits of the byte have we processed? And then we're going to have some sort of reader. So maybe we're going to call this reader, who's a type, and then we're going to say reader is reader. Okay, and then we're going to do the same thing where we have like a function that returns an instance of the reader based off of, I think it's any type here. Any... Am I high? What's the function name there? It's, oh yeah, any type. I don't know why it's not auto-completing, but so we're taking a reader, and then we return a Huffman reader where the type we're passing in is a type of reader. Boom. And so here we just say Huffman. I guess here we just say the reader is the reader. Current byte is equal to 0, and the byte progress, we're just going to say, we've already gone 8 bits through this byte. And now this guy's going to have some sort of like functions on it to do some shit. So I guess a next function probably makes sense. And he's going to return a U8. BGW, you're also doing it for learning purposes, but there's also a bit writer in the stdlib. Yeah, I saw that. I think that I don't want to use it, but I'm not sure. Because I know that I'm going to be iterating this guy bit by bit, So I don't know if using like the full-on bit reader in order to pop one bit at a time makes sense, you know? Uh, but yeah, not sure, not sure. What else is this guy gonna have in him? So I guess we'll just start by saying we're gonna like walk our Huffman tree. So here we're gonna need the tree. So here we're gonna say const Huffman is equal to import Huffman zig, and this is going to be our tree is going to be a Huffman table. Sorry, we called it a table. Feels a lot more like a tree, but sure, we'll call it a table. Fuck it, blaze it. And maybe we're gonna look at like current node is going to be a like where in the table are we currently looking at. Okay. And this guy certainly is going to have like, I guess we're also going to want to store like our like max length, right? Like when we're going to iterate over our reader, but we have to know when we're done. So we're going to have to like say how far, like what's like the maximum that we could possibly get to, as well as how many bytes have we currently read? Which means that this guy's gonna have to take in a table of Huffman table. And I guess, again, I feel like my default here should be take things by pointer, right? Like, right now, my Huffman table stores an array list, which isn't really a large amount of data, but I don't know that it's gonna stay that way. So probably taking a star Huffman table here makes more sense. I think. And then here, I just say my table is equal to the table. Current node is going to be the table's nodes. Probably I should just put an API on here to say like get root node index or something. So here we take in our self, and we return a usize, and we just say return node self nodes items len -1. Okay. So now I can say that the current node is going to be the table root node index like this or something. I don't know. Bytes read is going to start at 0, and max len is going to have to be passed in. Okay. Okay. So, every time somebody calls us, we are going to, since function arguments are always immediate, the compiler can decide to pass large structs as pointer, even if you don't explicitly make the argument a pointer. Oh, because I can't modify function inputs. So interesting. I like that. So I can just trust the compiler there. Even here though? No, because here storing the inside the Huffman reader, now all of a sudden table is mutable. Right? So if here it's mutable, then it would have to copy the whole structure, and so I should store it as a pointer. I'm starting to understand like the argument for function arguments, but not for struct arguments or struct parameters, whatever the fuck you want to call them. You're also saying that I don't have to dot star all the time. I can just do this. Only works for function arguments. Okay, that makes sense. I'll keep that in my head. Here we're going to say this is equal to self and unreachable for now because I want to check that everything is still compiling. I like kind of working these things slowly instead of getting to the end and being like, holy fuck, I did everything wrong, and then getting mad and then quitting. So here we're going to say that our reader is going to be a Huffman reader, and he's going to wrap some reader. So can we do like buff reader? Is that like a thing that exists on this guy? And we're also gonna have to pass in our table as well as our max len, which is the input data len here. And then this is gonna look like doing some sort of like while we can extract some value from reader.next. I guess we're gonna like push this thing into a new buffer. So we'll call this like var decompressed is equal to some sort of array list. And then we have to de-init this guy, so defer decompressed de-init. Like this. Oh boy, I don't know Zig, but I know Huffman code, one of them. Sure, yeah, nice. We got 1 of 2. You're ahead of me, I've got 0 of 2, so we're getting... I'll catch up soon, I hope. Okay, so for each value that we get from this guy, we're gonna push this into decompressed. So append val. And then at the end, we should be able to do some sort of like check that the decompressed is equal to the input. So we can say std debug print decompressed is going to be some string that we extracted, and we're going to say that that came from decompressed. Okay. So we don't compile because self doesn't exist here, so we have to say const self is equal to built-in compiler function this, which returns the type of the most inner struct. No field or member named reader on a buffer. Oh, fuck. I was kind of hoping that that existed. So let's go back to the Zig standard library docs and see. So array list. He has a function writer, which returns the writer API. But is there really no reader API? So there's like readers who comes from std.io fixed buffer stream buff items, I guess. Okay, yeah, I kind of figured that it would just be in the other spot. So fixed buffer stream, he takes in a buffer and he returns a fixed buffer. Okay, perfect. It's kind of odd asymmetry to that. There, like, yeah, that's one thing I've kind of noticed. Zig feels like it's got all of the right pieces in place, but so far I've kind of felt like what I guess will exist isn't what there is, which might just be like a unfamiliarity problem. But like I would just assume that if there's a writer, there would be a reader method. And I get why you would do it this way, where you're like, well, we have this like API already that exists for slices, and there's a slice in your buffer, so why would we put another one on it? I get it, but that's one thing that I really, really liked about Rust, is like, I felt like every time I guessed something, it was right. Which might just mean that like I align better with the language, but, or I'm more familiar with it or whatever. Okay, so we'll say buff reader is going to be a std.io fixed buffer stream, which takes in, well, the entire stdlib is up for audit before 1.0, so basically the entire thing is temporary. Ah, I see. So is it that like the author is using the standard library as a way to like find some convergence? And so if there are things that like don't match up with themselves in the standard library, that's just like kind of by design, because I would get that would make a lot of sense. That's probably how I would do it too. Okay, so buff here, we're going to say that our buffer has items in it. And we're going to pass those items into the fixed buffer stream. So now we have a reader, and then we can pass that to our reader. Okay. U3 cannot represent value 8. Right, so I guess we'll just store this as U8. Fuck it. Doesn't matter. Okay. Expected optional type found U8. Oh, okay. So our reader next has to say, hey, I might be a U8, but I might also be finished iterating. Okay. And this guy has he might fail because we might allocate in our array list append, which is a very cool, like, no other language does this that I've used. They're just like, fuck it. Mallocs will always work. We'll crash your program otherwise. But this is like, no. That's an error, and you need to propagate that error. This needs to be items, I think, for this to build correctly. Perfect. Okay. So now everything, all of like APIs are sitting in the right spot. And now we just have to fix this unreachable. So what do we do here? We look at our current node and we kind of say, depending on where we're currently looking, we are going to read one bit from the input stream and walk the node, walk the list. So I guess the API here is kind of like implying, since we are returning a U8 no matter what, we're kind of implying that at each call to next, we're at the root of the tree, right? We're not like midway through a decompression of some form, which means that we don't need to store a current node. Instead, we just say here, hey, root node index. We'll get this now. And here we'll say var node index is the root node index, and he might change over time as we loop through. So we're going to say while true, probably. I don't know. Maybe we'll break. Maybe there's some condition here. But we're going to read one bit from our reader. So we're probably going to want to like make a function next bit. And he's going to return, we'll call it a U8 for now. Maybe you can call it a U1. That would be kind of cool. And here is going to say, if the byte progress is greater than or equal to 8, we need to read a new byte. So self reader read. No. What is this like? I guess we want to look at specifically the fixed buffer reader, but I guess technically fixed buffer stream. This is gonna. Oh, he has a reader API name that we're supposed to call. Fuck. So this is supposed to be like this. Okay. Does that mean that this reader? Okay, yeah, this is like a generic type. Okay. I want to be painfully pedantic and say you're requesting a byte to read. Yeah, it might not come out. But the API will tell us that in a second. Okay, so this guy has some sort of like read. And we are going to read a single byte, read byte, nice. So here we can say read byte. And this is going to come into current byte. And self byte progress is going to equal 0. Okay. Then we are going to return current byte shifted right by the byte progress. And only the bottom bit. So I think that's fair. I also like saying I want to be painfully pedantic is like, hell yeah, brother. Like painfully pedantic is my bread and butter. I love it. Truncate will do that for you. Zig. Okay. Ziglang.org. Is that where I want to go? And I want to look at the documentation. Where was I? Zig documentation. Truncate. Convert integer types, chopping off bits. Is that what I want to do? I guess that is what I'm doing. However, this is well defined when it's out of range. And I think I'd rather the error, right? This should only ever be... Oh, I guess... Okay, wait, which way does it truncate? Out of range. Yeah, I guess that is exactly what I want, huh? I do just want that. So I want, like, truncate this. Yeah, okay. I'll take it. So we're going to switch on next bit. Oh, so this has to return an error on failure. Which means that this is going to also maybe error out. Which means that in our loop, we have to while try reader next. Okay. And then here we're going to say const next bit is equal to self next bit. Try. We have to try, of course. Always try. Sometimes succeed. And we're going to switch on that next bit. And what's kind of cool here is because this is a U1, which is like a crazy thing for the language to have built in. I love it. It just means that we don't have to worry about this like other case. We only have two options, and those are the two options that we want. Is this the right thing? Switch. Okay, so I don't write a dot, I just write the number. So this is like 0. I'm gonna say we're gonna take the left branch. And 1, we're gonna take the right branch. And I don't really know what that means yet, so I'm just gonna hit unreachable here, and we'll figure it out in a second. So I guess we are going to, at the beginning of each thing, we are going to check what our current node is. So we're going to look at the tables, nodes at the given node index. And if he is a leaf, we just return that value. And if he's a branch, I guess we need to look at that branch in some way. Maybe like this. And so if we are 0, we look at the left side of the branch. Right? And if we are here, we say the node index is the right branch. So here we just say branch left and branch right. That feels like it's it. Right? Maybe. Nodes, items. We have to look at the slice inside. Expected U3, found U8. So here we have to int cast here. Which should never fail because we've already checked that it's never greater than or equal to 8. So we should fit. He was infinite looping there, which is interesting. So maybe we can, oh, we need our exit condition here. So here we need to say, if, we need to, 1, every time we return, we need to increment bytes read. Like this. And then we need to say No. Yes. We don't increment byte progress, which is a very good point. So var ret is equal to this. And then here we need to return ret. And before we do that, we say self byte progress plus equals 1. And we need our exit condition from this. When are we going to return null? And it's if self bytes red is greater than or equal to max len. Return null. This has to be self. And this says U8, which is stupid. This should say U1. Now a sketch. Hell yeah. Hell yeah. Look at that. Look at that. Decompressed ABDDD. That's what we wrote here. Hello, my little friend. Oh, he doesn't like that. Okay. So he did like ABDDDD. That's fine. But when I say hello, is that fine? No, interesting. So we are hitting the end of stream too early when reading. So what we should do is we should print out the buffer items, which we do, which is empty. Why is it empty? Whoa, 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 whoa. Other characters are not on the table yet? Oh! Fuck, you're right. I have to generate the table based off the input data. Of course, of course. Yeah, so we define the input data at the top, and then we do everything else in the same order. Hell yeah. Okay. So now we should be able to say, like, say hello to my little friend. Which turns into this, and decompress, we get it back, which is super fucking sick. Super sick. And now we can do something like, let's look at the look at the compression ratio. So we can say, compression ratio is equal to some floating point thing, probably an F. I don't actually know. I'm just guessing. And this is going to be, buff items len over input data len. And probably we need to cast to a float, because I assume that Zig is going to like do float truncation to int cast, but sorry, when doing integer division, it will do like truncation, I assume. So here I probably have to do like as F32 here, and then if it's like C, which I would imagine it is, then the other thing will auto upgrade to an F32. Oh, but it won't. Int. Okay. Int. No. How do I... It's not int cast anymore. It's like float cast or something. Float cast. Nice. Oh, you're saying I should use float from int. What's the difference? Convert from one float type to another float from int. Yeah, okay. And do I specify whether I want 32 or not? So he doesn't... I guess I probably have to stash him somewhere then, because he's not going to know if this is going to be a float 32 or float 64 here. As F32 float from int? That's fucked. I don't like that at all. Oh, that's terrible. Okay, but we can try it. So, incompatible type. So I have to do that twice? Oh my lord. Oh, maybe the as will figure itself out from this time, though. It could. If it knows that the thing on the left is a float 32, then it might try to do the thing on the right as a float 32 as well. Nope. Nope. That's, who could ever read that? Invalid format string, F. What do they want? I'll just put nothing. See if it figures it out. Okay. So that did something, but why would it format this way? Okay, so I want to do something like look at the formatting rules, and he wants what for floats? Floating point values in scientific notation? Is there a non-scientific notation? Only scientific notation? That's crazy. Really? What if I put... Oh, decimal notation. Oh, D is not like in printf, where it assumes that it's an integer. Ah, okay. And then I only want like some, so yours, like I want to fill with zeros, but I probably don't have to, so can I just say like 1 precision or something? Yeah, there we go. Let's do 3. Okay, yeah, so we are taking up just under 50% of the space by doing it this way. And if we do it like, just chuck in some ASDFs in there, I assume that our compression ratio will get higher. 4.0. So actually not by that much. And I think if we do like ASDF, since every letter is unique, oh, that is actually a very heavy compression ratio though, because we don't have to use the whole 8 bits for every character. Interesting. All right, that's pretty cool. Pretty cool. Okay, so there's this thing called canonical Huffman encoding, where the idea is if I have like this tree that has like A, B, C, there's actually a bunch of like equivalent trees here in terms of space, right? This could be the same as B, C, A, or C, any combination of like C and B swapped in here. These are all the same. But there's like a canonical encoding that says like, basically they define the order. So the order depends on your like character inputs. And you can then just store your Huffman codes as basically like the lengths that each letter in your alphabet use. And I'm trying to decide if I want to do that right now, because I had it on the list. But we're kind of at like a natural ending point, an hour 40, and this was like a pretty good, I'm pretty happy with this result. And I think that there's a good chance that if I start this, I will not be happy with the results. When I'm at like 2 hours and 15 minutes, I'm like, fuck, I can't get it, fuck. So I think it makes sense to call it there. Is it how they store it in the file? In zlib, yeah, that's how they say that they're going to store it. I have to, I mean, as far as I understand, I haven't really read it too closely, but that's my understanding. But yeah, I think I'm going to call it there. I think that's like pretty good progress. So what do we do? We added this like Huffman writer. Do we do anything like interesting here? Nothing too crazy. Just like generation of the code book. The reader was slightly interesting. The reader we used like we made like this iterator that iterates over bytes, and kind of learned a little bit about like zig storage and stuff along the way. It's crazy that this is all we did today. It felt like more. But I guess that's kind of what happens when you're learning something new, is that things just go slower than you'd expect. Cool. Okay, so thanks for watching, guys. If you like what you saw, we're streaming most days at around 2 o'clock Pacific time, and we stream for like, hopefully closer to 2 hours. So today we're at like an hour 40, which is probably about like the lowest I'd want to cut it off. We're working on this like zlib reimplementation for now, for the purposes of learning. But there's a bunch of other stuff that we've hit in the past. So we've done a lot of Rust. We've done some like operating system stuff. We've done some like neural network stuff in Python, some web dev, some virtual file system Fuse stuff. We kind of hit all the boxes just kind of depending on what I find interesting. Yeah, there's like what else, like 3D geometry, stuff like that. So if you want to check that out, there's a YouTube link in the Twitch description. If you don't see the link, because on some people don't, it's the same username on Twitch and YouTube. There's also GitHub links there, same username again, where all code for projects eventually ends up. This project isn't up there yet because there hasn't been like a natural, like, here is the first chunk of work that I'm considering done. But it will go up there eventually, hopefully. If you're on YouTube, there should be a Twitch link in the YouTube description. And if you want to swing by and say hi because you're online between 2 and 4 Pacific time, you should check it out. You only shoot for 2 hours. Where are you going to, Lamau? It's more that there's like other stuff to get done in a day, right? Like I have to do some like pre-reading, some post-reading, some like video upload, like clean up, whatever. And also it's hard to keep going at this rate for longer periods of time. So 2 hours is kind of like the nice middle ground. Okay, so I'll argue. You go to work. You work like an 8-hour work day, right? How much of that day are you actually fucking coding, right? It's not a lot. For me, at my last job, it was very little, like extremely little, because of like there was just like a lot of other stuff going on. And so like you can actually get to the point where you're like, well, I'm only like, if you're coding for like 2 hours in a day, that 2 hours is like insanely fucking productive because you're doing like other meetings and like whatever operation stuff for the rest of the time. But personally, I've found that like in that environment where I was only coding for a little bit a day, that little bit of time was much, much, much more effective than if I go for a full 8-hour block, right? If I sit down in the morning and I code for 8 hours and just fucking go, the amount of stuff that gets accomplished does not scale linearly with the time that I'm spending on it. Because I believe that there's a lot of stuff going on, like with like stupid human mental brain power shit, where you're just like, oh, I need time for my subconscious to chew on a problem. I need time to relax. I need time to like recharge. I can't just like sprint forever. I have to like take breaks. So I find that 2-hour blocks is quite effective. Yeah, not that I have to fucking justify this to you. It doesn't fucking matter if you think that I work hard or not. I don't fucking care, but I do think that it is interesting that like I very strongly don't believe that just doing more time results in more stuff done. It definitely results in worse quality. So yeah, we shoot for 2 hours. That's where we're at. Thanks for watching, guys, and I'll catch you on the next one. Bye.